If you have two devices, depending on whether they belong to the same VLAN or whether the VLAN is handled by the L3 switch or by the gateway, the routing will be different. For layer 2 switching, when the two devices are on the same VLAN, everything is handled by the switch. It's layer 2, there's no routing. But if you configure the VLANs to be handled by the L3 switch, the routing is L3 routing, while the switch, the traffic won't go through the gateway. But if you configure the VLANs in the regular way, that means the VLANs are handled by the gateway or by your main router. The traffic has to go via the gateway, right? Depending on the different situations, you may wonder what will be the performance difference. We all understand that there are a lot of factors, for example, firewall rules, for example, ACL rules, but in this video, let's try to exclude those factors, focusing on the pure network throughput. This is my lab environment. I use EFG for this video. The reason I pick EFG instead of say UDM Pro is, first, it has a lot of CPU cores, which means theoretically it can support more routing activities. Secondly, it has two SFP28 ports. I configure them using link aggregation, so the link shouldn't be a bottleneck when it comes to routing. Then when it comes to switch, I use this enterprise 10G 24-port switch. The reason is all the 24 ports, they are RJ45, so I can easily connect to my computer. And then it does have two SFP28 ports as well. So I also configure them using link aggregation so that it can have a 40 gigabit uplink to the router, to the gateway. Then when it comes to testing devices, computers, I use 4 rack mount servers to run 4 Linux virtual machines. Someone may wonder why you don't simply use multiple ports within one server, right? Why you want to use 4 physical servers? The reason is some of the network interface cards on these 4 rack mount servers, they share the bandwidth among multiple ports. To avoid the potential conflicts, I decided to use 4 physical servers so we cannot blame the machine anymore. So then in the right side, I have 4 different Mac machines. They also use 10 gigabit links connected to the switch. Okay, so this is the lab environment. Then in UniFi network controller, if I go to settings, networks, you can see I configured 4 additional VLANs, 66 and 88. They have the EFG as router. So they are the traditional VLANs handled by the gateway. Then I also have 166 and 188. They both have the switch as the router. These 2 VLANs are handled by the layer 3 switch. So in this video, in the 3 different scenarios, I'm going to use different VLANs for different devices to do the testing. And as I mentioned earlier, when it comes to firewall rules, I have everything default. For ACL, I have none. And for deep inspection, it's off. So basically, it has nothing configured except for the new VLANs. Let's start with the first scenario, L2 switching. In this scenario, all the 8 devices, they are in default network, the same VLAN, which means all the traffic will be handled by the switch. This purple link has nothing to do with this scenario, no matter what's the speed. And for this enterprise switch, I already set all the 8 ports to native VLAN 1. So we are ready to start the testing. On the screen, you will see 8 terminals. I already SSH'd to the 4 Linux and the 4 Mac machines. I also validated their IP addresses. You can see on the screen, they all have the .0 subnet IP address, which means they are in VLAN default. Okay, then in the 4 servers, let me start iPerf3 server. Okay, started. Then in the first client machine, let me run iPerf3 client in this way. I'm going to run it in bi-direction, so both sending and receiving. Then I will run it for a long time. So you can see the performance okay. It's not ideal, of course. There might be different reasons. For example, my cheap network interface card or my bad cable qualities, or maybe even due to the MTU setting, whether it's using jumbo frame or not, right? There might be different reasons, but at least you can see most of the time close to 9 gigabit per second speed. I'm good for now. Then switch to the second client, run the client in the same way. Okay, let it run. Then in the Mac machine, okay, you can see the Mac machine's speed is pretty good, right? So that means the bad performance in Linux has nothing to do with the switch itself. Then for the other Mac machine, okay, they are all very busy now. At this moment, if I go to the enterprise switch, go to port manager, here I can see the activity and even rates. I will explain in more details in next scenario, but I'm not happy with the display on the UniFi network controller. I want to know their accurate real-time speeds. So then let me SSH to the switch. I prepared a custom shell script to calculate the speed. In the next scenario, I will show you the source code, but now let me simply run it, show you the results. Okay, so you can see for each part what are the speeds, and this is the aggregated speed, 70 for each direction. In theory, the maximum throughput for the 8 parts is 80 gigabits, right? So we are close. I'm good with this L2 switching testing. And because now we are in the switch, let me show you the top command result anyway. You can see the CPU and memory, they are okay, and the IRQ is 0%, and the sort IRQ is also 0%, because all the L2 switchings are handled by the hardware, not by the software, not by the operating system, by the CPU. No, that's why from top you cannot really see whether the switch is busy or not, but we know the switch now is super busy. Okay, let's move on to the second scenario. In this scenario, let's test routing, the Inter-VLAN routing through the router, the gateway. In the UniFi network controller in network setting, you can see for VLAN 66 and 88, they are managed by EFG, by the router itself. And in the diagram, I will put these 4 machines under VLAN 66. They will act as IPv3 server, and the other 4 machines in VLAN 88. They will be clients. So let me go to the switch setting for the enterprise switch. I already set the corresponding ports, the 8 ports, to VLAN 88 or VLAN 66. Okay, the settings are done. Then from these 8 machines, let me show the current IP address. As you can see, the IP address shows they are in the correct VLANs. I'm ready to start the testing. In the 4 servers, let me start IPv3 in server mode. Then let me kick off the testing in the first Linux client. I still run it in bi-direction mode. Let me start it. Okay, the first surprise. In previous testing, you can see when the 2 machines are in the same VLAN, we can achieve close to 10 gigabit per second speed, right? But now it's only about 3.5 for each direction. So the only cause is because the traffic now is being routed by the gateway, by EFG. So even it's the EFG, the most powerful UniFi router, it still can only achieve about 3.5 gigabit per second throughput each direction for each connection. This is not satisfying. Let me kill it. So let me run in 10 parallel connections. Let's see whether the situation will be changed. Okay, it's better. You can see I can achieve close to 8 gigabit per second each direction, even though still not exhausting the bandwidth of the 10 gigabit connection, but it's better than just one connection. Now I'm using 10 parallel connections, right? So which means the gateway itself has the enough CPU memory power to support concurrent connections to achieve higher rate, but for each single connection, it can only achieve about 3.5 gigabit. Okay, so then move on to the second Linux client. This time, let me directly use parallel 10, right? Start it. Similar situation, about 8 maximum. Worst case scenario is even 2 or 3 gigabit. And you can see the other one is already impacted. So these two are impacting each other. And you can see there are some retries already. The packets are conflicting with each other. Okay, move on to the first MAC client. Similar way, bidirection, 10 parallel. Okay, exact same situation. Move on to the very last client. Okay, so while they are running, let me go to the UniFi network controller to see the real-time traffic. In the switch view for this enterprise switch, you can see the system does have the bar chart for the activity, and it does have columns for RX rate and TX rate. However, maybe by design, the software is not very aggressively pulling the data. So you can see it's just very static display. It's not really real time, and some of the readings don't really reflect the real world situation. So I'm not happy with this rate display. I don't trust them. So to get the readings I trust, I decided to go to the backend through SSH to the switch. There's a command, it's called switch control. If you use port show as parameter, it will tell you the real-time situation. For each port, you can have columns for receive bytes and transmit bytes. However, these two columns are not about rate. It's about the total bytes since the switch restarted. This is not really what I want, but I can use these two columns to calculate the rate. So I prepared a script. Let me show you. Because this video is not about shell script programming, so I'm only going to briefly explain what this script does. This is a shell script, the classic shell, because that's what this switch has. I first define the port numbers I'm interested in. There are 26 ports for this particular switch, but I'm only interested in 8 ports, right? So I list them out in this ports parameter. Then I specify the intervals. Basically what I'm saying is every 10 seconds you do a calculation, and then the divisor is just to get the gigabit per second. I need to do some calculation, right? Then I get a before picture, then sleep for 10 seconds, then get another part statistics for the after image. And then the remaining part is to use the AWK command to grab some substring from the output for the individual part and then do the calculation. Of course, I need to take the after number, subtract the before number to get the delta. I will skip the detailed calculation, it's boring. Then at the end, I will print out for each part what's the rate. Then at the very end, I will calculate the summary, the aggregated rate. So this is the brief logic about the script. So now let me run the command. It will take 10 seconds. This number is what I'm really interested in, the aggregated throughput. So you can see, even though I configured link aggregation, theoretically I have 25 plus 25 throughput for the uplink to gateway, but I only achieve a little bit over 25, which means we already reached the gateway's Inter-VLAN routing capability upper limit. It can only support such throughput. You can see from the UniFi network controller for port 25 and 26, you can see the TX rate and RX rate. Add them together, you will reach the similar number. So let me run the program again. Okay, similar result, a little bit over 25. That's it. As the last thing to check, let me SSH to the gateway, run top command. You can see this time the top command shows totally different situation. For CPU, SI means software IRQ. It's for the network traffic processing by the CPU. You can see all the top processes. They are Ksoft IRQD, and they are busy processing the Inter-VLAN routing. and the CPU only has about 6.6 idle. So even though this gateway has 18 CPU cores, it's almost used up all the CPU resources to process the Inter-VLAN routing. Okay, let's move on to the third scenario. This time, we will use the VLAN 166 and 188 for the testing. They are both managed by the L3 switch. So let's see for this type of inter-VLAN routing, whether the performance is different than previous, more traditional gateway-based routing. And for all the 8 parts, I already changed the part definition. So now they belong to the correct VLANs I want. The 4 here, they belong to 166. The 4 here, they are in VLAN 188. And for this testing, this purple link, it doesn't matter because the routing will be handled by the switch, not the gateway. Then for all the 8 devices, I already validated their new IP addresses. They are in the correct VLAN. Now let me start the 4 IPv3 servers first. Remember for previous scenario, just to increase the performance, we used 10 parallel connections, right? But this time, because it's new scenario, let me start with just 1 connection. Let me try. Start it. Okay, you know what? The performance is not too bad. It's still about 9 gigabit each direction. Let me queue it. Then let me use 10 parallel connection. Let's see whether it will improve anything. Not really. Let me revert back just to use the default 1 connection. Move on to the second pair. Okay, similar situation. Move on to the Mac machines. So for Mac, interestingly, it seems it's not impacted by the routing at all. It's still very good speed. Then move on to the very last pair. Still very good. Now they are all very busy, right? So from the UniFi network controller, you can also see for the 2 purple links, the 25 gigabit connection, they don't have any traffic because the routing is not through the gateway. In the same way, let me simply run my custom script to find out the real-time speed for the 8 parts. Okay, you can see the aggregated throughput is very good. It's on par with the same VLAN L2 switching performance. So if you are interested about the CPU utilization for the switch, let me show you. This type of routing, based on what I observe, is still handled by the hardware, not by software, not by the CPU of the switch. That's why it's so fast. That's why the switch CPU is still lightly utilized. Okay, let me summarize. For L2 switching and L3 routing, the setup can almost exhaust the hardware capabilities. For the 10G parts, I don't see bottleneck anywhere. But for the inter-VLAN routing through gateway, it's limited by the processing capability of the hardware of the gateway. In my case, I can only achieve a little bit more than 25 gigabit. So the link aggregation setup doesn't really add a lot of bandwidth. And another interesting finding for the inter-VLAN routing is if I just use 1 connection, I can only get about 3.5 gigabit per second, even though I can achieve the aggregated throughput about 26 or 27. But for single connection, I can only achieve 3.5 gigabit per second. This ends the video. Thanks for watching.